Hi guys, so a lot of you have questions on the day 8 assignment. This was yesterday's assignment. Life has a history web, what was it called? Life has a history web account or something like that. Okay, so you open this link on your Google Classroom and you get this. Click on the link below and answer the following questions. So then you're going to select this, or if you click on it, it'll take you to the website. Okay, so Life has a history. Welcome to Life has a history. Read each screen carefully all the way down to the row of the orange dots at the bottom of the page. Here are some tools that can help you. So this will take you back to the beginning if you click on this. Previous bird, next page bird, and close window turtle. Okay, so let's go back real quick. If you make a copy of this document, excuse my children in the background. File, make a copy. And okay, then you are going to, you can type in your answers into this document. So now whenever you answer the questions, you can even change the color of your writing so that your writing is a different color than the question if you want to. So let's make it blue. All right, so as you navigate through Life as a History, keep your eyes open for answers to the following questions. I believe these are in order with the clicks. So the first question we're going to be thinking about. Find the information describing the 30 million species of living organisms. Of that 30 million, how many are not animals? You'll have to use your math skills to come up with the answer. All right, so get all of that ready, make your copy, hit pause now. Once you're ready, I will start going through this website with you. All right, so we're going to begin. We're going to click Next. Welcome. Life has changed a lot during Earth's long history. These changes have resulted in the large number of different organisms that we see today, and those we see in the fossil record. In this tour, you will learn how and why these changes have occurred. As you move through the tour, you can find definitions to scientific terms used in the tour by clicking on the terms in purple. Have fun and enjoy this tour through time. Life is very diverse and always has been. Many different taxa, groups of organisms, including animals, plants, fungi, bacteria, and protists, exist on Earth. The organisms that exist today and those that have existed in the past help us understand the history of life. How many different species of living things do you think exist on Earth today? Fewer than 10 million, between 10 million and 20 million, over 30 million. Well, it would be a guess on most days, but I remember reading, find the information describing the 30 million species. So, clue. All right, here we go, over 30 million. 30 million is a big number, too big to visualize. Let's take a closer look. So there may be as many as 30 million species of animals, plants, and other organisms on Earth. The total number of animal species currently known is about 1.9 million. Click on each of the numbers below for a look at the member of some animal groups. So more than 1 million of these species are arthropods, insects, crustaceans, arachnids, and their kin. About 70,000 more are mollusks, snails, clams, squids, octopi, and their kin. Another 20,000 are so flatworms, and about 25,000 are roundworms. Just over 4,600 mammal species are known today. That actually seems less than I thought. Okay, but animals are only a small part of the picture. All right, let's go back to our question. Find the information describing the 30 million species of living organisms. Of that 30 million, how many are not animals? Well, how many are animals? 1.9 million. Okay, so 30 million minus 1.9 million will give you how many aren't. So you need to do that math and write your answer there. Okay, next question. Pause if you want to do that real quick. Number 2, find the three, here, I'll write that in here. 30 million minus 1.9 million equals, and you need to find the answer. All right. My color changed again. That's silly. Okay. Find the three lens view comparing the oceans through time. Name one animal common to today's oceans whose relatives were also around 470 million years ago. Okay. So let's go to the next page. Large part of the biodiversity is made up of other organisms. So there are more than 287,000 known species of land plants, from liverworts to redwoods. Liverworts, that's a fun name. 72,000 species of fungi, some resting on your feet and on your pizza. Ugh. And over 80,000 species of protists, ranging from microscopic single cells to 30-foot kelps. Can you even imagine how many bacteria there must be? Why didn't we make these pictures all the same size? Remember, if we represent all the known groups of organisms by a picture of appropriate size, we get something like this. Remember that this represents only the species we know. New species of insects, roundworms, and other small organisms are being found all the time. The picture of the butterfly and roundworm might have to be enlarged 10 times to show our estimates of the true number of these species alive today. The diversity of life we have today is a result of evolution. The simplest way to define evolution takes just 3 words: change through time. Life has a long history, and it's been changed throughout the history, resulting in biodiversity that we see today. Imagine for a moment that you have a lens through which you can view the oceans across geological time. What would you expect to see? Which organisms would be the same as today? Which would be different? Click the 3 lenses below for a peek at life in the sea through time. Okay, so I forget the question. Find the 3 lenses viewing comparing the oceans through time. Name one animal common to today's oceans whose relatives were also around 470 million years ago. So honestly, we need to choose an animal that is in this box and here and here. All right, so let's learn about the longest time. Oh goodness, we get another thing. Ordovician period, 470 million years ago. Okay, well, this animal looks familiar to me, and so do these sea urchins. Okay, this is what you might have seen on shallow sea floors 470 million years ago. The big tentacled fellow in the middle and his friends in the background were the dominant predators of that time. These cephalopods were distant relatives of squids and octopi with large straight shells that would reach 9 feet in length. The big one has snarred a trilobite with its tentacles. Trilobites were one of the first arthropods to exist on Earth. In the foreground are some, here you guys can't really see, some corals belonging to an extinct group known as Rogose corals, which are distantly related to the corals of today. Below are fossils of Trilobite ceroris, the Rugose coral Zaphrantius, the straight-shelled nautiloid Orthoserius. Wow, okay. Okay, so we're going to close out of that one. Remember what animals it talked about. I think I have an idea of which one is through all the years. All right, Middle Jurassic Period. Oh, we all know about the Jurassic Period. I was watching Jurassic Park the other day. Okay, this is what you might have seen about 160 million years ago if you looked out over the ocean. While dinosaurs dominate the land, sauropods stroll along the shore. Large marine reptiles like the ichthyosaur, Ophthalmosaurus, ruled the seas. The ichthyosaurus chased down some squid, while ammonites, extinct squid relatives, swim in the background on the left. Right over here, maybe? Below are fossils, squid. Wow. It's crazy to think of, like, under all that soft tissue, this is the bones inside, right? Okay. So that's the next one, present day. The ocean today. This is the marine habitat of today. A reef at Inuwatak, an atoll in Marshall Islands. Coral reefs provide habitats for a staggering number of life forms. Here are some of the other common forms of modern marine life. So what do you see in these pictures? Beep, 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 beep. That we saw in all 3. So what animal has been around for like ever? Write your answer here. I hope that I don't need to give you any more clues. All right, number 3, find the timeline. How many millions of years did dinosaurs exist on Earth before they came extinct? Another math problem. Okay, so let's click next. Evolution has occurred over billions of years of Earth's history. As you watch the seconds tick by on a pocket watch, it seems impossible to visualize the billions of years that the Earth has existed. Most of us never need to think beyond a few tens of years. So a history of billions of years is hard to imagine. How old do you think the Earth is? I think over 4 billion years old. You are right. The history of Earth can be traced back 4.6 billion years. Imagine putting some major events of Earth's history on a timeline. Click on the box of the timeline where you think each event should appear, starting with the appearance of the first dinosaur. Okay, the first fish. Oh, okay. So I'm figuring this out. Okay, Earth forms. First fish. No. I'm confused. What do I have to do? Find the time. How many millions of years did dinosaurs exist on Earth before they became extinct? Okay. So the first fish. Am I doing this incorrectly? I'm confused. See, sometimes teachers even get slipped up. Oops, try again. What am I doing wrong? Where you think each event... Oh, okay. So maybe I have just overloaded the system. Let's try again. Here? Try again. Here. No. Here. Try again. Okay. So the first fish was 50 million years ago. Dinosaurs were extinct. No? I don't know a lot about dinosaurs. Okay, they went extinct 65 million years ago. First life. Okay, first life was 3.9 billion years ago. First dinosaurs were 225 million years ago. First multicellular life. First land plants. Plants might be first, right? And then modern humans. Okay, so the question is, find the timeline. How many million years did dinosaurs exist? So dinosaurs came 225 million years ago, and they were extinct 65 million years ago. So how long did they exist? 225 minus 65. You can do the math. Okay, find and name at least 5 things other than bones that can be preserved as fossils. Okay, the history of Earth can be traced back 4.6 billion years. How do we know these events took place? Well, we look at evidence. One of the best sources of evidence is fossils. Fossils provide evidence for the evolution of life. Fossils are not just bones. Shells, tree trunks, footprints, pollen, even tiny organisms may form fossils. Paleontologists study the fossils they find to learn more about the Earth long ago. Click on at least 3 of these fossils to learn more about them. Tyrannosaurus rex. This is the skeleton of Tyrannosaurus rex, a dinosaur that lived about 65 million years ago. When all the bones of the T-Rex were taken out of the earth, cleaned, prepared, and put together, this skeleton looked like this, which we've all seen if you went to the Science Museum. Or do we have one there? I'm not sure. All right, let's do this. These fossils are the shells of brachiopods. This is pictured 380 million years ago. Okay, what's this? Tiny bacteria can become fossils and conditions are right. There are remains of 850 million year old bacteria called cyanobacteria. So bacteria can be, and fossils, what's another one that doesn't look familiar? Oh, footprints. So we have bones, footprints. The question said, name at least 5 things other than bones. So we have footprints, bacteria. Okay, that's bone. We know these are... What's this? Oh, impression from the bark of tree-sized plant. So, plant impressions. I used to do these as a kid in mud. Excuse me. Let's see. This tiny fossil is a foraminiferan, a foreign for short. Forams are organisms that make shells of calcium carbonate, glass, or sand grains. Most forams are barely visible to the naked eye. However, in some places, forams are so abundant that their fossils formed in great masses of chalky rock. So, I'm going to put chalky. I'm going to just put forams. And we need one more. What have we not looked at? Cone-bearing tree. Okay. We saw that. Then in oceans, they had no shells, bones, or other hard parts, but did leave behind fossil impressions. We talked about impressions already. We talked about footprints. Okay, let's see if we can find some more. Fossils help us understand how life forms are related. It's not easy to tell exactly how these four animals are related. However, by comparing features of these fossils and living organisms, we can get a clearer picture. I don't know what else to add here, so I'm going to go with 4 for right now. I'm going to make this blue. Find a picture of Deinonychus and 3 of its relatives. What feature do the birds all share that Deinonychus does not? Okay, so I'm going to pause the video for right now. I want you guys to try to work on the rest on your own. My daughter has a Zoom meet with her teacher right now, and this is going on 17 minutes long. So work on the rest. I will put up a video to help with the rest, but if you've done it on your own, good. But it's going to be a while before I can get the rest up. So do what you can, and then I will post the next video coming up soon. All right, talk to you guys soon. Bye-bye.